Science and technology for the blue economy. I'll focus on wind farms today. That's something that's been going on a lot locally. Rhode Island has really led the way with marine spatial planning, as Brian mentioned, really was a nationwide leader in marine spatial planning kind of a decade ago, getting ahead of other countries, or other states rather. Something to definitely be proud of from the Rhode Island side, and we do have the only actual operating wind farm right now at Block Island, as many of you are probably aware. And we did a lot of work out there, and I'll show you some pictures of the seafloor from there. So what we do at Inspire, and where the SPI in Inspire comes from, is sediment profile imagery. And I'm going to show you how that works. It's this camera. What you're seeing there is a plan view image. We take those as well. This one is probably around 2,000 meters below the surface of the water. So we're talking deep. We can also sample in shallow systems. We can go down to 4,000 meters with one of our cameras. And this is the most fun for me, is looking. I get to look at pictures of the seafloor for my job. I have to do other things, make maps, write reports, but the most fun part for me is looking at these images, getting to see interesting things. I see, sea stars, different fish, burrows, and we get to determine structure and function and health of the seafloor from these images. And we can tell a lot by capturing them in situ, which means as they are versus taking them outside of their natural environment. So I'll show you briefly how this works. For sediment profile, SPY, plan view is PV. That's that aerial image down. I have a video which should be muted. Let's make sure that works. So the system descends to the seafloor. It's on a cable coming from the boat. A trigger is fired. You get a flash and a plan view image. It continues to descend to the seafloor. Once it hits, the weight is released, and this carriage with the prism on it slides down into the sediment. Another trigger is activated, and we get a profile image of the sediment. These are worm tubes. That's also what these are meant to signify in the animation. Let me just explain a little, go back to this slide a little bit to explain kind of how that works. It's essentially like taking, if you had who knows about ant farms? Anyway, ant farms. So if you if the ant farm was underwater, and you could take a camera, just like your regular, very nice, high quality camera, but a point and shoot camera, put it against the side of your ant farm and take a picture. That's essentially what we're doing with these images, but it's in the water, below the sediment surface. What you see there is a nudibranch crawling on top of what we call the sediment water interface, so where the water column meets the sediment. And that sharp prism that you saw go into the sediment has a camera facing down, and there's dissolved, the deionized water, so it's a clear path of water. So even in a turbid estuary like Narragansett Bay, which has had a number of SPY surveys completed, you get a clear path, so you get this high resolution image, even if there's turbidity in the water column, because you have clear water that the image is taken through. There's a mirror on the back of that prism, so it bounces off, and we get a picture. So it's pretty fun. It's been around for 40 years. Narragansett Bay was some of the places this technology kind of cut its teeth in a lot of northeast estuaries. We've done some really cool surveys on the overall health of the bay. There was one done by colleagues and mentors of mine in 1988, and a fellow grad student of mine with me. We went back out and sampled all those same stations again in 2008, so it was 20 years in between, but we were able to say we went to the same places, used the same technology, and assessed the health of the bay, which had improved since then. And my colleague just got another funding to go out, and they went out last year, so 10 years, so we shortened the gap from 20 to 10 years. And we're really seeing improvements and ecological changes in the bay. A lot of that's tied to improvements for wastewater treatment and so forth. But SPY has a lot of roots here in Rhode Island and in Narragansett Bay. So on to offshore wind. We have our one tiny little wind farm here at Block Island, but the landscape is changing very quickly, and developers are moving very quickly to develop offshore wind farms in all of these different areas. The government, so the Bureau of Ocean Engineering Management, sets here are areas where you can develop, here's a lease you can buy, and then we go out and we help sample those. And what we're trying to do is help them determine if it's an appropriate place for the technology, if there's anything they need to be concerned about. These are pictures of what we call hard bottom habitat right near Block Island. So this is not exactly where they put the turbine. They put those in sandy places. But this was nearby and there was concern about anchoring there, so we used our camera as well as towed video to take images and quantify what type of habitat was there and monitor for effects from construction. We also do some really cool things with integrating data. So we take the images, but we have here what's called backscatter. It's a type of mapping technology that gives you hardness, softness of the seafloor, and we can integrate our data. So no matter where you are working with science and technology, engaging in these industries, you can collaborate and pull different sources in, which is a really fun thing, and it expands, hopefully, your view around that. I like this one. This is another type of that acoustic mapping of the seafloor, and we saw these depressions from these jack-up barges. So initially they were using a construction barge, towing an anchor, and we found some of those with our video. And then that wasn't working so great, so they got these jack-up barges, which you can see they literally jack up off the seafloor and raise it up so they can do the construction on the blades. And we could very clearly identify those footprints, which probably by now are gone due to storm activity. But it was pretty fun to map. Well, those four was that big one called the Brave Tern. Then there's these little, like this one here has the 3 legs. So it's one of these little guys that moved around a little bit. We've also done some fisheries work. This is another way to be engaged with the blue tech from the wind farm side. And our fisheries scientists at our company also work directly with the fishermen. They're going out on the boats. So those folks who are already in blue economy, fishermen clearly are probably one of the older forms of blue economy, are helping with the science and helping drive the science for responsible development and responsible work with the fishermen in this space.